The next one I'm going to leave for you to work on your own. This is similar to the setup that we just were looking at, but this time you're looking for the tension in the cable. So you can use the previous one as a model to guide you.
You just multiply the mass and acceleration?
No, because it's vertical now, so you have to take into account gravity. So, like I say, use that problem with the fish as a model and go through the steps, free body diagram, and go from there. Alright, the next one that I would like to look at with you as an example problem is this one. And the setup again is very similar, but there is some interpretation that will take place at the end. We now have a bucket being lowered vertically by a rope. There is 163 newtons of tension in the rope at some particular moment in time. And so we need to find the acceleration of the bucket and then answer some questions related to that. So once again, first order of business is to draw the free body diagram for the bucket. And as always, we have the weight downwards, which is mg. And in this case, the only other force is the tension upwards. So Newton's second law says that the sum of forces, which in this case is tension plus weight, equals ma. And I cannot stress how important it is to just be consistent in how you set these problems up. It's always sum of forces equals mass times acceleration. Filling in what we know, there's 163 newtons of tension. It's positive because it's in the upward direction. The weight is downward, so we'll put in the negative sign. The mass of the bucket is 12. And g is 9.8 equals 12 times the unknown acceleration. So simplifying the left-hand side,
45.4.
okay, 45.4,
Huge equals
12a,
3.78.
and we have 3.78, and that is meters per second squared. Alright, so that takes care of the first part of the problem. Now, is the bucket accelerating up or down? Well, we answer that by looking at our acceleration. Is it positive or negative?
Positive.
It's positive, and we set it up so the positive direction was upward. So it is accelerating upward. Is the bucket moving up or down?
Down. Down. Saying the bucket is lowering.
You are very observant. I'm impressed.
So it's done, right?
Yeah.
Give away the answer within the question. Because it says so.
I'm impressed. You're observant, and that is a very good thing. Ironically, that was not the intention of the problem when I typed it up. Let's, for a moment, assume that that word lowered is replaced by the word moving vertically.
Then it would be moving up.
How do you know?
Because acceleration would be negative and would be going down, but since acceleration is positive, going upward? Or is the acceleration obviously always constant every time?
Here's the question you have to ask yourself. Does the acceleration
Never changes.
depend in any way on the direction the object is moving? And the answer to that is an absolute no, it does not.
Of course not.
So here are the possibilities, and with our modified statement of the problem, it turns out we cannot tell which direction the bucket is moving, because it could be that the bucket is being lowered, but you are slowing down the rate at which it's being lowered. That would be a positive acceleration. It's kind of like when you're going down in an elevator and it stops at the floor you're getting off. It has to accelerate upward to stop you. On the other hand, if you are already stopped and you start moving upwards, then your acceleration would also be upward. Or if you are moving upward but you move faster upward, you are accelerating upward. So there's a variety of scenarios where the acceleration can be upward, and that includes both moving up and down. So keep that in mind, because acceleration is only telling you about the change in velocity. It does not tell you what direction the velocity is. That's really important to remember. I could actually explain it very nicely with tangent lines using calculus, but we won't do that here. All right, so just be very careful about making assumptions about the direction of motion based only on knowledge of acceleration. Yeah, as you were just saying, in this case, if this were all we knew, we could not determine the direction the bucket is moving. Okay, the next one.